Complex problems video number 2. In the previous video we multiplied complex numbers and divided complex numbers. In this video you'll see 3 problems where we're going to solve quadratics and have complex solutions. So we want to solve this quadratic. I'm going to tell you in advance this will have complex solutions. You can't factor, so we will have to either complete the square or use the quadratic formula. In this case, I'm going to use the quadratic formula. Which is negative b plus or minus square root b squared minus 4ac all over 2a. I have my quadratic already set equal to 0, so I know my a is 3, my b is 4, and my c is 2. So using the rule of substitution, I'm going to have negative 4 plus or minus the square root of 4 squared minus 4ac all over 2a. So this is now going to be negative 4 plus or minus the square root of 16 minus 4 times 3 is 12, 12 times 2 is 24, all over 6. Simplifying inside the radical, we're going to get negative 4 plus or minus the square root. 16 minus 24 is negative 8 all over 6. So we have the negative inside the radical. We're going to have to take that out by putting I on the outside. So now we get negative 4 plus or minus I square root 8 all over 6. Simplifying even further, we know that negative 4 plus or minus I is equal to 4 times 2 over 6. So we want to get perfect squares, which is negative 4 plus or minus square root of 4 is 2, so we have 2i over square root 2 over 6. Now we have to simplify even further, because it's negative 4 over 6 plus or minus 2i square root 2 over 6. Simplifying negative 4 6, we will get negative 2/3 plus or minus 2 over 6 reduces to 1/3. So we have 1i square root 2 over 3. We can leave it like this to emphasize that it's complex, or you can leave it, since we have the same denominators, as negative 2 plus or minus I square root 2 all over 3. So in one long page view, you can see what we did step by step and solved for n. As you can see, this is what all n and it's not x, it's n, because our variable was n. Let's try one more. Here we want to solve. So I'm going to use the square root property. So I'm going to do 3p squared equals negative 4. The reason why I'm using the square root property, because there is no p term. There is no linear term. So I'm going to divide both sides by 3 and get p squared equals negative 4/3. Next, I will take the square root of both sides. And remember, when you take the square root, you got to do plus or minus. Square root of p squared is p equals plus or minus the square root of negative 4 over the square root of 3. Most common mistake here is students leave it as is, but you have to rationalize the denominator, which means you have to multiply both sides by square root 3, because you cannot have a denominator with a radical. So rationalizing down the denominator, multiplying both sides by square root 3, we're going to get plus or minus square root negative 12 over square root 9, which is plus or minus I square root 12, because we have the negative inside the radical, all over 3. Next, you have to reduce the square root 12, which is 4 times square root 3. So you get plus or minus 2i square root 3 all over 3. And that is what P equals. Last example. We have 2m squared plus 5 equals negative 5m. So solve. So we want to set the equation equal to 0. So I'm going to add 5m to both sides. And we will have 2m squared plus 5m plus 5 equal to 0. And I'm going to use the quadratic formula. Why? Because I have A, B, and C, and I know I can't factor. And I'm not going to complete the square, because I prefer to use the quadratic formula. So m is going to equal to negative b, which is 5, plus or minus the square root of 5 squared minus 4ac all over 2a. So we're going to reduce and simplify. Inside the radical, 5 squared is 25, minus 4 times 5 is 20, times 2 is 40, all over 4. Negative 5 plus or minus the square root, 25 minus 40 is negative 15, all over 4. I'm going to simplify this by taking out the negative and replacing it with I on the outside, because the square root of negative 1 is I. Remember, square root of negative 1 is I. Negative 5 plus or minus I square root 15 all over 4. And you have to realize, can you reduce 15 or simplify it? It's 3 times 5. 5 and 3 are not perfect squares. So your answer is negative 5 plus or minus I square root 15 all over 4. That finishes up the examples that deals with complex numbers. If you have any questions, please see Mr. Hubble after class or before school.